Kia ora team. Kia ora team. Today we're going to have a look at using our insulation resistance tester. Let's get straight into it. Well, firstly, what is an insulation resistance tester? And I have one here. You can see at the top it says insulation tester. Let's have a quick look at the functions. Like our multimeter or most other meters that we use, we see we have a switch in the middle, a rotary switch in the middle, which allows us to select various functions. On this particular meter, you can see I've got a voltage test function here. It says that'll test AC and DC voltage, and also a continuity or ohms tester here. These are additional functions that are on my meter. They're not necessary for the insulation testing function, but they're nice to have. The insulation tester itself at its core is a ohm meter. It's for testing resistance, but it's special. It'll do a job that our normal multimeter won't do, in that we can see here that we've got 250, 500, and 1000 volt functions on this. You may have those functions, you may have something slightly different, but all of the ones that we have should have 500 volts on there at a minimum, because that's the one that we're going to use. And what those mean is actually we're going to do our resistance test, and the meter's going to put out 250, 500, or 1000 volts, depending on the one that I select. In this case, 500. So we'll actually get 500 volts across my test leads, and we're going to come back to that in a minute. But the first thing we'll talk about is what is this for. So it's, as it says, it's an insulation tester. It's for testing insulation. It is an ohm meter. It's going to give me a reading in ohms. But what I'm really trying to test here is the resistance of the insulation between two conductors that are not supposed to be connected together. Typically, an example of that would be the phase and earth conductor in any sub-circuit in an installation, or in an extension lead, or in an appliance, for example. We definitely do not ever want the phase and earth conductors to be touching together. We want to keep them apart all the time. So this tester is going to allow us to do that by using 500 volts to stress the insulation. Now you might ask, why do we want to do that? Why do we want to use 500 volts? What is that for? Well, the easy answer is this. If we look here, we will see ASN ZS 3000. We are in section 8, verification, where all of our testing information is. And one of the tests here, 8.3.6, insulation resistance, it says the integrity of the insulation is stressed by applying a direct current at 500 volts. So the easy answer to that question is, well, the standard says I have to. But there's a little bit more to it than that. We want to use 500 volts because we really want to know that that insulation is good. We're really trying to make it work hard so we can find the tiniest leak through that insulation that might exist, because that's going to cause us a problem later. And we use 500 volts because that's above the absolute max value we will see on any normal circuit. And so we know that if our insulation is good at 500 volts, then it must be good at 400 volts on a three-phase circuit, or 230 volts on a single-phase circuit. Just note here where it says that we must use 500 volts, there is an exception, and it says where there's equipment that may be damaged by 500 volts, we could use 200 volts instead, or rather 250 volts instead. But that doesn't apply most of the time. Most of the time, we're just going to stick with 500 volts. So if we go back to our meter, then we can see I've selected the 500 volt range. And when I do a test, I'm just going to test like any resistance test. I touch the leads together. But at the moment, you can see nothing is happening on the screen. That is because this puts out 500 volts. And I don't want it to be on all the time where it may accidentally might bite me. So it won't do anything until I push the test button. There you can see I've got a reading. At the moment, it says OL overload because I haven't got the leads touched together, so it's not picking up anything. It's saying that there's a very, very high insulation resistance reading there. I've also got a lock button here, so I can hit test and then lock, and that's going to hold that on. So now I've released the test button and my meter is still operating. I just have to be careful that I don't touch the probes. And you'll see that if I touch them together, it's going to give us a resistance reading. load setting. Let's try that again. Just hold down the test button and touch them together. And you can see I go from a very high reading to a very low reading. Now it's saying 0.000. So it's saying I've got a dead short circuit there, which obviously I do. I'm touching my leads directly together. Okay, so what do we use this for? Well, we need to do this in installations and on appliances. And if you want to know more about the specifics of that, there are other videos that will tell you. Go back into this video series and you'll find those videos. But as an example today, we're just going to have a look at this. So I've just got an ordinary piece of cable here. You can see that it's just ordinary piece of TPS, and I've stripped the ends off. And we can see there that obviously in this cable, the phase and earth conductors should be separate. Of course, they should be separate. There's nothing about this cable that tells me that there would be any issues. So were I to do an insulation resistance test on here from phase to earth, clip onto the phase there and onto the earth, what I should find is that this cable is perfectly fine, and I should get a very, very high reading for insulation resistance because there's no connection between the phase conductor and the earth conductor, so it should be a high resistance between them. And I push the test button and pop my test lead on, and in fact it confirms it. It's saying overload. That's a very, very high reading. This meter goes up to 4,000 mega ohms. That's 4 billion ohms. So overload means it's over 4 million ohms. Just swap this lead out for another one. Click on that. Just free up my hands a little bit. And let's see what happens when we do have a fault. So if I pop this on here, we will see that I've now got my meter connected to the phase and earth, and I push the test button, and once again I get a very high reading. But I've got the other end of this lead exposed, so if I touch those together, you should get a circuit. There we go, and it's back down to 0. So you can imagine if this cable was buried in a wall somewhere and I only had access to one end, and there was a fault somewhere on that cable, I've just been able to pick that up using my insulation resistance tester to tell me that there is some sort of fault in there. Now, just in terms of using that high voltage, a couple of things there. Why do we use that high voltage? As I said, to stress the insulation. In this context, we can imagine that our insulation is like the wall of a water pipe. So the actual physical outer of my water pipe. Now, if I wanted to test the pressure capacity or whether my pipe has any leaks in it, one way to do that would be to push a high pressure through it. And in this case, we can think of our voltage as high pressure. So if I put a higher pressure onto my pipe than I would normally see while it's running, and there's any tiny leaks in it, they should become apparent. I'll see water springing out of those leaks. And the same with our cable here. If I'm testing the insulation at a much higher voltage than I would normally use, then I'm stressing that insulation, and if there's any tiny leaks in it, I should be able to find them. Once again, we must do this on our installations. Every sub-circuit in an installation, when I install a new installation, or when I install a new circuit in an installation, or work on or modify a circuit in an installation. And we must also do this on our appliances when we're doing our testing and tagging. We're doing an insulation resistance test. And as I said, go and find the other videos for more specifics on that. One last thing on this test in particular, or rather on this tester, is you're probably sitting there thinking, 500 volts, hold on, isn't that dangerous? I'm sure I can be killed from 230 volts, so how can you be playing around with a 500 volt thing? And it is true, it is 500 volts, and it will give me a shock. It will not harm me. There is not enough energy supplied by this meter to be able to physically hurt me, but it will give me a shock. If I touch the ends while the tester is on, it will give me a little shock. Not a great idea. I guess if you have a career in the electrical industry and you're doing this kind of work, you'll probably find you accidentally shock yourself with your meter. But you wouldn't be able to buy these off the shelf just like this if they were actually hazardous to your health. So we can safely assume that yes, it will give me a little shock, and it'll give me a fright, but it won't hurt me. So just one precaution on this: be careful, don't shock yourself. And if we look really, really closely here, we might just be able to see. If I hold down the test button and short these together, I can see there just a little spark in between the terminals. I don't know if you can see that on the camera. I can see that. Yeah, there's a little one there, and so that's just the 500 volts arcing across between the probes as I touch them together. Okay, that's all for this one. Go ahead and jump into the other videos on insulation resistance testing and an installation and insulation resistance testing for an appliance. I will see you there. Thanks.